All right. Again, today we are continuing our discussion of Chapter 8, Section 2, which is covering the Pythagorean Theorem. Today we are going to discuss the converse of the Pythagorean Theorem and some things that go along with that. The first of those things being a new vocabulary word, Pythagorean triple. Okay, new vocabulary word, Pythagorean triple. A Pythagorean triple is defined as a set of three positive integers, and that is key. They have to be positive and they have to be integers, which could represent the side lengths of a right triangle. Now, what that means is that these three numbers, whatever they happen to be, these three integers, would satisfy the Pythagorean theorem. In other words, whatever those three numbers are, they will make this equation, a squared plus b squared equals c squared, will be a true equation. That is what makes them a Pythagorean theorem, or a Pythagorean triple, a set of three integers that satisfy the Pythagorean theorem. Now keep in mind that whatever those three numbers are, the largest number has to be c. So when you look at your choices, whatever those three numbers are, the biggest number has to be your c value. Okay? So for example, 3, 4, 5 is a Pythagorean triple. The biggest number in that group is 5, so that's your c value. The other two, it doesn't matter which one you call a and which one you call b. If we check the Pythagorean theorem, we have 3 squared plus 4 squared, and we are asking, is that equal to 5 squared? Well, 9 plus 16 is in fact equal to 25. So this would be, yes, this is a Pythagorean triple. It's a set of three positive integers that fulfills the Pythagorean theorem. Okay? So that's the first thing we're discussing. It's a relatively simple idea. The key things here being that they have to be positive, they have to be integers, which means they can't be decimals, they can't be fractions. Okay, they can't be roots. Those are not Pythagorean triples. Those sets of numbers could still fulfill the Pythagorean theorem, but they wouldn't fit this definition, so they wouldn't be considered Pythagorean triples. Okay, so let's do some examples of what we're going to do with that. We'll start off doing a couple together, and then I'll have a couple that I'd like you to try. Starting with, let's see here. Determine if each set of numbers represents a Pythagorean triple. Use words, numbers, and or symbols to justify your answer. So we have here the numbers 9, 12, and 15. So in the chat, please tell me which of those three numbers would be the c value, 9, 12, or 15. Which of those three numbers in the chat, which one is the c value? And remember that the chat gets saved, so I can go back later and see whether or not you're participating. There we go. Yeah, the biggest of those three values is the c value. C is the biggest number. 15 is the biggest number, so 15 is c. The other two, it doesn't matter which one you call a and which one you call b. A and b are interchangeable. So are they, the first question you ask yourself is, are they integers? The answer there is yes. All three of these numbers are integers. They're whole numbers. Okay, and then we can turn around and we can check the Pythagorean theorem. So the second part, the second requirement is that it fulfills the Pythagorean theorem. So we can check that. Okay, we say, all right, 9 squared plus 12 squared equals 15 squared. Yes or no? And we go through and we check. Well, again, this comes down to, do we know our perfect squares? 9 squared is 81. 12 squared is 144. And 15 squared is 225. Add 81 and 144 together, and you get 225. So when you get to this point, it's either going to be true or false. In this case, this is a true statement. So our answer would be yes. 9, 12, 15 is a Pythagorean triple. Take a second and try the other one on this page. Try the other set here. See if they are a Pythagorean triple. 3, 7, and 9. Check those three. I'm going to give you about a minute to do so while I double check attendance and things of that nature. Okay? So please get ahead of me. Try the other one. Okay, hopefully by now you've had enough time to get to an answer. Again, the key things here are, one, we have to correctly identify our C value. The C value here would be 9, because 9 is the biggest of those three numbers, which means the other two, 3 and 7, are A and are B. It does not matter which one is which. So the setup on the homework is going to be, I'm going to have blanks there where I want you to fill them in. So you'd put those numbers in the blanks. Okay, then we're going to go in and we're going to be checking the Pythagorean theorem to see whether or not it is true. So we would have 3 squared plus 7 squared, and we are asking ourselves whether or not that is equal to 9 squared. Now, you don't necessarily need to show this step here. You could go straight to 58. Is it equal to 81? And the answer to that is no, it isn't. That's a false statement. So the answer to our question here would be no, 379 is not a Pythagorean triple. Okay, so on your cameras, please show me a thumbs up if you got that right. If you don't have your camera on, you can raise your hand digitally and then put it down again. So I want to see how we did. Did okay? All right, good. All right, looks pretty good. Okay, so let's look at a couple more of these here. I want you to try these next two, and we'll see how we do. We may not do the final two. Okay, so try these next two here. See what we do. The numbers are a little bit bigger. Again, take your time. Make sure that you get C identified correctly. Check your Pythagorean theorem and see whether or not these fulfill the definition of Pythagorean triple. About another 30 seconds to get both of those completed. And remember that you need to make sure that you're identifying the largest number as being C, and make sure that you are considering whether or not the numbers provided are integers, which has not been an issue so far. Okay, so please, please, please be very careful with that. C value has to be the biggest value. And we are checking the Pythagorean theorem. "15 seconds. Okay, it's in the chat for letter A. Which number is C? Which number is C? In the chat, type in the number that is C. See, I got somebody. Remember, the C value has to be the biggest number. Okay, so when we're looking at these 24, 60, and 45, biggest number is 60. So 60 is your C value. The other two are interchangeable. Doesn't matter which one is A, which one is B. They are also all integers, so I don't have to worry about that portion. Instead, I'm going straight to checking the Pythagorean theorem. So we have here 24 squared plus 45 squared. Does that equal 60 squared? All right, so we go in and we check this. 24 squared. 24 times 24 is 576. Just going to double check my memory. Yep. So we have 576 plus 45 squared, which is 2025. And we're asking whether or not that equals 60 squared, which is 3,600. Well, pretty clearly, 2025 plus 576 is not even 3,000. It is 2,601, which is not equal to 3,600. So that is a false statement. And our answer would be no. This is not a Pythagorean triple. Okay? On the other one, just real quickly, which of those numbers should be C? Again, in the chat, which one is C? Looking good. Okay, good. The biggest number is C, and the biggest number is 34. So 34 is your C value. They're all integers, so we don't have that problem. Again, if one of them was a fraction or a decimal, then we could instantly say no, because they have to be integers. Okay? So we run through and we check here. 30 squared plus 16 squared equals 34 squared. And we're checking to see whether or not that is true. 30 squared is 900. 16 squared is 256. And 34 squared is 1,156. So we are checking to see whether or not this statement is true, and it is. So since this is true, our answer would be yes, those three numbers form a Pythagorean triple. Okay? So either in the chat or on your camera, we're going to go scale of 1 to 4, 1 being I totally don't get it, and 4, I feel like I don't need to do any more examples of this. I've got it. Where are we at here? Okay, looking good. Okay. So again, we're going to we're going to still be doing this along the way here in the next portion of the lesson, but I do want to go ahead and move on since we've got all 3s and 4s, it looks like. And we're going to go into the other set of stuff from this lesson. So we are going to skip the final example here of the Pythagorean triples, and we're going to go into this other information to finish out the section. Okay, so first of all, as a review, we already have on the books a theorem called the triangle inequality theorem, which says that in any triangle, doesn't have to be a right triangle, we're just talking triangles in general. If we've got the 3 side lengths of any triangle, the 2 smaller sides have to add up and be bigger than the 3rd side. We covered that back in chapter 5. So for instance, if we look at these 2 examples here, okay, and C again is the biggest side, then if we look at a set of numbers, I really want that to be green, like 10, 12, and 8, 12 would be C, and we can check to see whether or not A plus B is bigger than C, and that tells us whether or not those 3 numbers can be a triangle. Not a right triangle, just a triangle. So if we look at that, 10 plus 8, is that greater than 12? The answer would be yes. Okay, so these could be a triangle. Those 3 numbers could be a triangle. Whereas on the second example here, C is 15, A is 7, B is 5. So if we check that inequality, 7 plus 5, is that greater than 15? Well, the answer there would be no, which means these 3 numbers are not a triangle. They cannot form a triangle because the 2 smaller sides have to, repeat, have to be bigger when you add them together than the 3rd side in order for those 3 numbers to represent the side lengths of a triangle. I think it was like 5-3 or 5-4 was where we covered that information. Maybe 5-5. Yeah, I think 5-5 was it. So there's actually an extension of this that allows us to look, instead of at just A, B, and C, if we look at their squares, A squared, B squared, and C squared, we can actually tell what kind of triangle we're looking at in terms of angles. So we can identify the triangle as being acute, obtuse, or right, okay? Just by comparing A squared, B squared, and C squared. If C squared is equal to A squared plus B squared, what kind of triangle is that? Put it in the chat. If A squared plus B squared equals C squared, what kind of triangle are we talking about? Yep, nailed it. Way to go. That is a right triangle. Has to be, because that means it fulfills the Pythagorean theorem, which is what we've been talking about, right? So if A squared plus B squared equals C squared, that means it's a right triangle. But as it turns out, if C squared is less than A squared plus B squared, then the triangle we're looking at has to be acute. And if C squared is greater than A squared plus B squared, then the triangle must be obtuse. Okay? Which is not the, it's kind of a cool fact. It's not super important, but it is a very interesting mathematical fact, which I'm just going to quickly double check and make sure I didn't say backwards, because I'd hate to screw everybody up. Just real quickly here, finding it in the book and double checking my information. I'm pretty sure I'm right about that. Yep. Okay, good. So I had to find it in the book. Okay, so that's what we're talking about here. So that 10, 8, and 12 up above, that was definitely a triangle because 8 plus 10 is greater than 12. We can also classify that, okay? So if we look at, A squared plus B squared is 10 squared plus 8 squared, which is 100 plus 64, or 164. And c squared is 12 squared, or 144. We can state that since a squared plus b squared is greater than c squared, 164 is greater than 144. Would everyone agree with that statement? That these three numbers represent an acute triangle, because a squared plus b squared, c squared is smaller than a squared plus b squared, or a squared plus b squared is bigger than c squared. Okay, that triangle is acute. So this triangle, this Pythagorean inequality theorem allows us to actually classify the triangle based on its side lengths. Only instead of telling us whether it's, isosceles, scalene, or equilateral like we usually do with side lengths, we can actually tell whether or not it's acute, obtuse, or right by comparing the lengths, the squares of the lengths. Okay, so we're going to do some more practice with this. All right. So again, if c squared is equal to a squared plus b squared, it's a right triangle. If c squared is smaller than a squared plus b squared, it is acute. And if c squared is bigger than a squared plus b squared, it is obtuse. So let's take a look at a couple more examples here and see where we get. All right, so 7, 14, and 16. Okay. Which of those three numbers, 7, 14, or 16, is going to be our c value? Type it in the chat. Good. Seeing the correct number popping up on my screen. The biggest of the three is our c, so c is 16, which means a and b are 7 and 14. So a squared plus b squared is one of the values we need to know. That is 7 squared plus 14 squared. So 49 plus 196. We would add those together. That is 245. C squared, which is 16 squared, is 256. So we ask ourselves, 245 to 256, which one is bigger? Well, 256 is. I'm going to write those the other way, because the way that the theorem is written, I'm putting c squared on the left in the theorem. So I'm going to put c squared on the left here. So give me just a second here. So we're asking ourselves, how does c squared compare to a squared plus b squared? C squared is 256, a squared plus b squared is 245. So c squared is less than a squared plus b squared. And if c squared is smaller, if c squared is less than a squared plus b squared, this triangle is acute. Now, there is a pitfall here that we need to make sure we're at least mentally checking, okay? So let me just explain that real quick, and then we'll go to the next one. I didn't check it because it's obvious in this case, but keep in mind, a plus b must be greater than c. You should always be checking that before you use this rule. Because if a squared, or if a plus b is not greater than c, it isn't even a triangle. You can't classify it as being a triangle if it's not a triangle. Okay, so if you come across one where that is not true, where a plus b is not at least greater than c, Okay, if it's not greater than C, then the answer is automatically no because it's not even a triangle. So you do have to watch for that. That's the trick question portion of this problem type. Okay? You have to check for that. Make sure that it's true before you start a squared plus b squared equals c squared. You're correct. I said that backwards. Somebody's got to thank you for calling me on that. I got so worked up about making sure I get this in that I'm not even saying this right. This is not true. 256 is greater. Yay, first screw up of the morning. Yay, Friday. Okay, that should be greater than. Which means it's not acute, like I said. That means it's obtuse. So, yay me, screwing things up. Okay, so I screwed that up. That should say obtuse, not acute, because c squared is actually bigger than a squared plus b squared. Good catch. It's been a morning, folks. It has been a morning. Let's do another one, and maybe this time Mr. Wills won't screw it up because it's 8:30 in the morning and his brain is not working. Okay, let's try another one here. I'll give you guys a second to get that one written down. We'll get at least one more in. We should have time to get at least one more in. I will also say that I came in this morning and realized that your homework assignment is not 100% ready to go up yet. So you're going to have to give me a little bit of time. It'll be up by the middle of second period. Okay. I'm just running behind this morning. But you got till Monday to get it done. So got to be at least one football game you can work during. There's at least one there you don't care about. All right. So let's try another one. Okay, 9, 40, and 41. Once again, we need to make sure we mentally check. We need to ask ourselves, which one is C? Well, the biggest number there is 41, so that would be the C. And then the A and the B would be 9 and 40. So you just have to quickly ask yourselves, is A plus B greater than C? Well, 9 plus 40 is 49. 49 is bigger than 41, so this is a triangle. That's the first thing we need to do. Then we figure out those values. What is a squared plus b squared? We do 9 squared plus 40 squared, which is 81 plus 1,600. That would be 1,681. Would be a squared plus b squared. Okay? Then we turn around and we say, all right, c is 41, so c squared is 41 squared, which means c squared is 1,681. What kind of triangle is this? Type it in the chat. Nailed it. Good. Okay. Again, if we compare our c squared to our a squared plus b squared, they are in fact this time the same number. Since they are equal, this is a right triangle. One more. Let's get one more in. We still have a little bit of time. Let's do another one. Okay. That's how quick it ought to go. It shouldn't take long. It is just calculation. It is a new type of calculation, but it's just a calculation and a comparison. Let's try one more. Everybody good here? Anybody need a little bit more time before we advance? That was a little bit quick. Everybody get what they need off that page? If not, raise your hand, unmute, and say, hey, hold up, or type something in the chat. We all okay? Okay, one more. Why don't you guys try this one? Oh, wait, hold on. Not that one. Try that one. The root one is one we're going to talk about in person. We'll talk about that one on Monday. Okay, try that one instead. 6.2, 13.8, and 20. Now, yes, those are not integers, but no, that does not matter in terms of this theorem. They don't have to be integers for this theorem. I mean, it does mean they can't be a Pythagorean triple, even if they're equal. but it doesn't prevent us from classifying the triangle. So again, consider which one is the biggest. Check a squared plus b squared. Check c squared, and classify this triangle, if it's a triangle. Don't forget to ask yourself that question, by the way. "30 seconds. Oh, getting close. 15 seconds. Okay, so how many of you, show of hands, you can raise it digitally or you can just say, show me on camera, say that this is an acute triangle? Good. How many say it's a right triangle? Also good. How about obtuse? Interesting. How many people say that this is not a triangle at all? You are correct. Again, we've got to check to see if A plus B is bigger than C. Okay, C is clearly 20. That's the biggest number. In your head, you should be checking to see whether or not A plus B is greater than C. And the answer here is no, it's not. Okay, 6.2 plus 13.8 is equal to 20. It has to be greater than 20 in order to form a triangle. So this is not only not obtuse, not acute, not right. It is not a triangle at all. And that should be the answer to the question. Not a triangle. Okay? So don't forget, you've got to mentally check for that. The two smaller sides have to be bigger than the third side in order for it to even be a triangle.